Okay, so this is my presentation on my Swift wireless fire alarm analysis. So to start off, I'm sure that we've all been hit by like a false fire alarm sometimes in our lives, and it is really annoying. And that's basically um, what we're analyzing. So we're analyzing a Swift fire alarm system that it replaces wiring with wireless transceivers. So it's installed in a lot of complex buildings because it can send wireless signals. But however, because these signals are wireless, it opens the door for a lot of unauthorized access and a lot of false alarms that will tend to happen. So, and the biggest security risk is going to be that someone's going to be able to disable an entire like building, and all the fire alarms in the building without ever actually touching any wire. And what we're analyzing is we're analyzing like how they would do this and how to like prevent that. And on the right here, you can see the network of the wireless network and the control panel. And on the top right, it's just the main control panel as well. So how we went about doing this is we did a lot of reverse engineering. Well, one of them was using the RF gateway transceiver, and it's just to understand how the data is being transmitted through the air. And then another one was using Ghidra, which is a decompiler, and we were able to map out like all the functions that the system uses. And this was mainly to like discover how messages are being sent and like the timing of them. And you can see on the right here, the bottom right, like the function tree and like how like the function tree works. And then the last thing is we did was create custom data types to translate raw machine code into understandable engineering structures. So on the top right here, we were able to decode like the messages into like something that like we can actually read and like something that we can analyze more clearly. Okay, and then for results, um, so one thing that we discovered is that we discovered a lot of the newer firmware versions are still vulnerable to something called a replay attack. And this just means that the system accepts old messages without checking if they're actually authentic. And another big thing we did was we were able to develop a Arduino-based device that can listen to the fire alarm system and respond if it's a real smoke detector or not. So as you get top left here, it's like the Arduino device built out, and the bottom left is the schematic that we developed. And yeah, the main thing is that we were able to like, I guess, learn more about how we can strengthen like fire safety protocols, and then also like learn more about like how the wireless part of it can affect the system, and also to like hopefully help public safety if like it ever comes down to that. So yeah, that's it.